Okay, everybody, this lesson is called Problem Solving Using Linear Equations. So we've been kind of on easy street with our lesson so far, and so my students have been kind of complaining that it's too easy. Let's pick it up a little bit. So, well, here it is, you guys. So this one's our first probably challenging lesson. So I need you to have your thinking caps on here, okay? So anyways, here, it doesn't matter what we graph on the x-axis and the y-axis, so we're going to be doing some graphing. So we're going to need some graph paper in this lesson. So if you don't have any, I'll give you some at school, or your teacher will anyways. So how can we know what equation we will need to write and graph? And so we'll have a couple examples here. And what happens when we add or subtract numbers from the existing function? Okay, so here's problem solving using linear situations. A car is going 40 miles per hour. That's what MPH stands for. Generate a t-chart and write an equation. Okay, so there's a t-chart. That's what they want. Okay, and then we're just going to put some random times in here, you guys. So let's just plug in. I just plugged in 1, 5, and 6. So the H stands for hours. That's because it's in hours, miles per hour right here. Okay, and if you guys ever heard of dirt problems, you guys, distance equals rate times time, D equals RT. Those are called, I call them dirt problems. So D equals RT. The distance equals your rate times your time, okay? Your rate is how fast you're going. So that's my rate right there. The distance is what we get when we do the rate and multiply it times the time right there, okay? So there's my rate right there. So this first one right here, my distance equals 40. That's my rate times time. And my time in this case is 1 hour. So 40 miles, they're going to go 40 miles. And doesn't that make sense? If you go 40 miles per hour, then after 1 hour, you're going to go 40 miles, okay? So after 5 hours, you just plug in 40 times 5. Distance equals rate times time, 40 times 5. And 4 times 5 is 20. So just add a 0 because it's 40 times 5. So 4 times 5 is 20. And if we just add a 0, it becomes 4 times, or 20 with a 0 on it, which is 200. Okay, so after 5 hours, it's 200. All right, now this one's a little harder to do, 40 times 6.5. It's not really, if you can recognize that 6.5 is the same as 6 plus 0.5, and then we did this before, the distributive property, distribute the 40 through. 40 times 6, well 4 times 6 is 24, so this is 24 with a 0, 240. And then 40 times 0.5 is the same as half of 40. So half of 40 is 20, so we just add 20 to that, okay? So 240 plus 20, and I get 260 miles, okay? All right, so this says graph the equation in A. Okay, well, remember distance equals rate times time, where your rate is 40. So our equation is D equals 40t. All right, well, let's think of this as y equals 40x, so we can create an x and y axes, because it does say graph, so we're going to do an x and y axes where y represents the distance and x is going to represent the time right here. Okay, so here's my chart right here, and look, think of this, you guys. It's going at plus 0, so I'll go here at plus 0, and then I use the slope. It's going to go up 40 over 1. Well, I don't have enough for 40 tick marks right there, so what I'm going to do is count the tick marks as 10, 10, 20, 30, 40, and count these as 1 right here, okay? You can have different scales on this axis than on this axis. So this axis, the scale is going to be 10. This axis, the scale is going to be 1 right there, okay? So there's that plus 0. It's going through plus 0. Now in the next graph, you guys, it's just going to be a graph in this quadrant. This is called quadrant 1. So on the next graph, I'm just going to graph quadrant 1. Okay, so there's the plus 0 right there. Now I'm going to go up 40 to the right 1 right there. Okay, so up 40 to the right 1. There's the point. There's the line. Okay. All right, so we went up 40 and then to the right 1, and then we graph that, and then you kind of saw what section C was saying. It says graph the point at 2 hours. Okay, remember this is hours, this is my x, and my x is my time. So we're going to graph the point at 2 hours and use this point to see how many miles this would be. Remember, this is distance right here, this is my miles right here. So what I'm going to do is draw a straight line up, a dotted straight line. So if you have a ruler or a straight edge, I'm just going to draw it straight up, okay? And then I'm going to go straight over right there. And then to me, it looks like it's going to be about 80 miles per hour, or 80 miles, not 80 miles per hour, 80 miles, okay? Doesn't that look like about 80 miles up there if you did the tick marks right? So So how many miles would that be? It would be, this is miles, so it'll go, here's 50, 60, 70, 80, okay? And if you plugged in 2 times 40 would be 80, okay? All right, okay, so here's another one, you guys. You can run 2 miles in 17 minutes. Generate a t-chart and write an equation that models what you would run at any given time. Okay, well, I'm just going to do 2 spots, you guys. They gave me one of them. So the time and the distance, okay? The time is 17 and the distance is 2 miles. Okay, remember, distance equals rate times time. Okay, so I'm going to do multiples of 17. So if I do 17 times 2, that's 34 minutes. So after 34 minutes, I just doubled this time over here, so it's going to double the distance over here. So after 34 minutes, it's going to be 4 miles right there. Now I'm going to move that down right there because I'm going to put a graph here in just a second right here. But what we need to do is write an equation of this guy, okay? So remember, distance equals rate times time. Okay, so look at these. I highlighted these. Which one's distance, rate, or time right here? Okay, what do you think 2 miles represents right here? It's going to represent distance. What do you think 17 minutes is going to represent? It's not the speed, you guys. It's going to represent the time right there. So if I put 2 in for the distance and 17 in for the time right there, okay? So remember, we want the equation to graph this thing. We want the equation y equals mx plus b because it says write an equation for this. So we want y equal mx plus b or d equals rt. Remember that right there? Okay, so what we're going to do is solve for r. Let's get r all by itself, and that's going to be my m right there. Okay, so what I need to do is get rid of that 17. All right, so we're going to divide both sides by 17 right there. Okay, and then so r equals 2 seventeenths. Okay, 2 seventeenths. Now, r is 2 seventeenths. That goes right there. So my equation is going to be distance equals 2 seventeenths times time. Okay, so there it is right there. Distance equals rate times time, or rate is 2 seventeenths, because here it is. Rate is 2 seventeenths, that goes right there, times time. Okay, all right, so there's my y equals 2 seventeenths x. All right, so I need a chart. Remember, I'm only going to graph the first quadrant. I left a space right here. Okay, and again, the tick marks on this, the scale on this side is going to be different than the scale on this side. I'm going to have to go up 2 to the right 17. Okay, it's going through 0, 0 again, up 2 to the right 17. So here's my graph. Okay, so from here, I'm going to plot the point right here and then go up 2 to the right 17. Just as long as your scale stays the same spacing on that, you're good. And if it stays the same spacing on that, okay? So there's the plus 0 right there. I did that. And then up 2 to the right 17. And I used a straight edge, you guys. I went up 2 and drew a straight edge over, okay? And then to the right 17, and so I went up 17 right there, okay, at 17. And right there is my point, so now I'm going to connect it up to the origin 0, 0. Okay, so there it is. I've graphed it right there. All right, I'm going to move it on the next page right here. All right, so this section says use this graph to predict the distance you would run in 10 minutes. All right, well, remember, this is my minutes down here. This is my distance. So if I go 10 minutes and go straight up, you guys, and I just drew a line straight up, okay, and then go straight over, that'll tell me right about there, it's a little bit past 1 mile, okay? It's not even quite 2 miles. I'm going to guess about 1.1 miles. Okay, now I'm getting a cold, you guys, so my voice is getting a little hoarse. I'm almost done, so good. Recall the distance equals 2 seventeenths times time. So if my time is 10 minutes, if you plugged in 10 right there, 2 times 10 is 20. 20 seventeenths is about 1.17 miles. Okay, I hope that makes sense, you guys, and take care. See you in class.